All right, let's go through a couple examples so we can get you guys ready for our Chapter 12 test. So the main thing in any of these problems that you want to ask yourself is, does order matter? Do we care? If you answer yes, then you're going to have a permutation somewhere in your problem. If it is no, then it's going to be a combination. And then lastly, does it ask you to find the probability? Well, if it does, if it says what is the probability, you need some sort of fraction, right? It was the total, or it was the number of outcomes over the total number of outcomes. So if you need to, take a second, write that down. I'm going to start this number 19 from the book. Also, if you would like to write down the whole problem, now would be the time to pause it and make sure you have it written down. You are eating dinner at a restaurant. The restaurant offers 6 appetizers, 12 main dishes, 6 side orders, and 8 desserts. If you order one of each of these, how many different dinners can you order? Well, you know you're going to order an appetizer, and you know you're going to order a main dish, a side order, and a dessert. Well, how many possibilities do you have for an appetizer? There are 6. If you're going to get one main dish, you have 12 to choose from. If you have 6 side orders to choose from, you have 6 possibilities, so that is another event, as we call it. And then you're talking about desserts. Well, there are 8. And we can multiply all these numbers together in order to get the total number of different dinners you could possibly order. So if you type 6 times 12 times 6 times 8, you get 3,456 dinners. Now this is from that day 1 of notes. It was the fundamental counting principle. We just have a different set of events. We multiply all the different possibilities together. This is similar to the type of problems where you are making a password with letters and numbers. So keep that in mind when you're doing your review. Next, if you want to write the problem down, go ahead and hit pause. If not, I'm going to keep going. You are buying a flower arrangement. The florist has 12 types of flowers and 6 types of vases. If you can afford exactly 3 types of flowers and need only 1 vase, how many different arrangements can you buy? Now, remember that question I wanted you to ask yourself. Does order matter? Well, does it matter in which order you buy your flowers or your vase? Does the question tell you that the order specifically matters? No. We just want to know the different combinations of types of flowers and vase that we can buy. So that, since we answered no to this question, we should use a combination. Well, I want exactly 3 types of flowers. And the florist has 12. So 12, choose 3. And means to multiply. We only need 1 vase. Well, there are 6 vases, and I only want 1. So remember, in previous problems, like with a deck of cards, we were writing that out. There are 12 flowers, and we want 3. And there are 6 vases, and we want 1. So that's where these 2 values come from. So you just need to type that into your calculator. And I'm going to do that right now. Type in 12, choose 3, times 6, choose 1. You should get 1,320. So we could buy 1,320 different arrangements if we buy 3 types of flowers and 1 vase. So the question, does order matter, is really important. Well, let's look at the next one. Find the number of distinguishable permutations of the letters in the word. So this tells us It's a permutation. We're trying to order the different letters. So let's look at pop. I have 3 letters in the word pop, and the P's are repeating 2 times. So n factorial over any number of repeating letters, which is just 2 factorial. So you can type that into your calculator, but with smaller numbers, I like to do 3 times 2 times 1 over 2 times 1 gives us 3. There's only 3 distinguishable permutations of the word pop. Let's look at the word June and the word Idaho. Are there any repeating letters in June? No, but there are 4 letters, so the answer is just 4 factorial. Since there's no repeating letters, we don't need to divide it by anything. Anytime, we talked about the, all right, let's back up here. We talked about the definition of a permutation. We said a permutation of n distinct objects can be found by n factorial. So that's what we're doing here. We have 4 distinct letters, and we're just wondering all the different ways we can arrange them. So that's 4 factorial. So similar for Idaho, there's no repeating letters, but there are 5 letters. So it doesn't have to be letters, it can be 5 objects of any kind, and the amount of ways that we can put them in different orders is 5 factorial. I'll let you guys figure out those answers on your own. Let's lastly look at Kansas. I have 3 letters. I know that A repeats twice and S repeats twice. N and K are just there once. So that means I have 3 factorial over. Since we're finding distinguishable permutations, I need to divide by the amount of times I see those letters. So 2 factorial times 2 factorial. And again, I'm going to let you get that answer all by yourselves because I'm confident you can do that on your calculator. Okay, one more example. This one is probability. Remember I said how important it was at the beginning to figure out what types of problems you're dealing with. In this case, it says find the probability. So I know I need some sort of fraction. So if I look at number 4 here, we're finding the probability that a dart thrown at the circular target shown will hit the given region. Assume the dart is equally likely to hit any point inside the target. So the center circle. Well, the first thing I need to do is find the area of that center circle. So if my radius is 2, I'm going to do my work over here. My area is 4 pi, right? 2 squared is 4, and the area is pi r squared. Well, that's the area of the circle. If I'm trying to find the probability that it hits the center circle, I need to find the entire area to go on the bottom of my fraction. So the area is 36 pi, because here my radius is 6, and I have pi r squared for the radius of, or for the area of a circle, excuse me. So that tells me 1 over 9, right? Pi's cancel. 4 divided by 36 is 1/9. You can leave that as a fraction, or you can put it into a decimal, whatever you would like. Okay, so the outside of the square. So outside of the square is anywhere in this blue region. So what I really need, of course, is the entire circle, which I already found as 36 pi. And I need to subtract the square, because then I'll be left with just that blue region. So if you look closely, one side of my square is 6, so the area of my square is 36, 6 times 6. And then I divide it again by the entire area of my circle. So 36 pi minus 36 divided by 36 pi. So if you take out your calculator, 36 pi minus 36 divided by 36 pi, you get 0.682. So the probability that it lands anywhere in that blue region is 0.682. All right. Number 6. The area inside the square but outside the center circle. So now I'm talking red. So inside the square but outside the center circle. So in order to find that, I first need the area of my square, which is 36. Then I need to subtract my center circle. So if I look at the picture here, the square without the circle just leaves the red area. So remember, the area of that circle was 4 pi. And again, I need a fraction. And since I'm finding the probability that it's thrown anywhere on this circular target, I have to again divide it by 36 pi, the area of the entire circle. So 36 minus 4 pi. 36 minus 4 pi. Everybody should be doing this in their calculators. When we divide it by 36 pi, our probability is 0.207. So hopefully this helps clear up some problems. We will do some more in class tomorrow, and if there's any other types you would like me to do examples of, you just got to let me know in class tomorrow, and I'd be more than happy to make another video for you. See you tomorrow. Good luck on your review.